In Unit 4, we spend a lot of time and energy attempting to prove that certain figures are congruent to one another. And so we're going to start this discussion with Lesson 1, talking about what congruent figures are, what that means for us, and begin the process for kind of analyzing the step-by-step to show that we have congruent figures. The entirety of the unit deals with congruent triangles, and we're going to start with this conversation looking at the big picture of all types of congruent figures. So our goal for this lesson is to make sure that we can recognize congruent figures. That's the first thing. Do we believe that these figures are actually congruent to one another? We may need to define what congruent figures are in order to understand that. But also we want to recognize the corresponding parts of congruent figures. So here is a functional definition, or formal definition perhaps, for the congruent figures. Congruent figures basically have the same exact size, and they are the same exact shape. You can perform some kind of rigid motion to either move or rotate congruent figures to fit over one another perfectly. All right? Maybe that rigid motion is something like a slide, where you can slide this rectangle on the left over this triangle on the right, or rectangle on the right, where maybe you can flip this figure. All right, here we have two hexagons. One seems to be pointing to the right, one seems to be pointing to the left. But if they have the same exact dimensions, if they're the same exact size, it doesn't matter which way they are oriented. If we could flip the figures, then we can understand which parts of each figure correspond to the other. Other times there is a simple rotation. Maybe that rotation is something as simple as taking a triangle and rotating it 90 degrees one way versus the other. We call these rigid motions because they do not change the dimensions of the figure. All right? For example, we could have two textbooks. Now these textbooks are printed in such a way that they will overlap one another perfectly. All right? If I have a book that's oriented sideways versus a book that's oriented vertical, they're still the same book. They still have the same content. They still have the same corresponding parts with the same corresponding measures. Right? So that brings us to the conversation about their corresponding parts match, all right, perfectly. And so this angle here in this triangle is going to match with that angle in this triangle. And then this acute angle is going to match with this acute angle. And this long edge of this triangle is going to match this long edge of the triangle. And once you reorient the figure, maybe that includes even redrawing the figure, you can understand which parts and pieces overlap perfectly. Congruent polygons have all of their corresponding parts congruent, as I've already mentioned. And so here we have a situation where a simple rotation between these two quadrilaterals, they could be trapezoids, but if we were to rotate these trapezoids, we would notice that point A and S would correspond, points B and R would correspond, points C and M would correspond, and points D and H would correspond. It's very important to recognize that not only do those points correspond to one another, but that means that the segments between those points, or the angles at those vertices, are also corresponding parts. Please make note that the corresponding parts of congruent figures are congruent. So if we've got point A corresponding to point S, we also have angle B corresponding to angle R, side CD corresponds with segment MH, and then the polygon itself, ABCD, is congruent to polygon SRMH. So not only do these pieces correspond to one another, but they are also congruent to one another. The obtuse angle here at A is going to be congruent to the obtuse angle here at S. The acute angle here at B is going to correspond and is therefore congruent to the acute angle at point R. This segment that connects point A to point D is going to be congruent to this segment that connects point S to point H. So not only do they correspond, but if they are congruent polygons, then those corresponding parts are also congruent to one another. Let's take a look at two polygons here, two triangles. Now these triangles, I've intentionally drawn them a little awkwardly, and you'll notice as you are attempting to draw them that you might notice, which parts correspond? And so as you're looking to draw that, let me encourage you to take a look at this congruence statement. This statement right here has a congruent symbol in it. We refer to this as the triangle congruence statement because it's saying that this triangle, UMC, is congruent to this triangle, FSP. But there is a lot more that's being said given this congruent statement. All right? So given this information, there are several things that we can and ought to note. The first is that the letters of the triangles are given in a very specific order. This tells us that point U corresponds with point F, that point M corresponds with point S, and that point C corresponds with point P. Given that correspondence, we can list all 6 pairs of corresponding congruent parts. Now those 6 pieces are, for these 2 triangles, they're 6 pieces because there are 3 angles, 3 pairs of congruent angles, and then there are 3 sides in a triangle, so there are 3 pairs of congruent sides. And we can start wherever you would like. If we would like to start with the sides, we can do that. If we'd like to start with the angles, we can do that. Most folks, if you've got the triangle congruent statement, you start by listing the points. So we would say that angle U corresponds to and is therefore congruent to the angle at F. That angle M corresponds and is therefore congruent to the angle at S. And then finally, angle C is congruent to angle P, as it corresponds in the order in which the points are given to us. So this kind of gives us a little bit of guidance to say U goes with F, M goes with S, and then C goes with P. That will also help us identify which sides are congruent. Looking at this picture, it's awkwardly drawn. You don't know if these segments correspond or if these segments correspond. Obviously, this is a picture that needs to be rotated and flipped, all right, in order for the parts and pieces to line up. Now, you can do that if it's helpful. I'm not going to do that right here, or I may do it in just a moment. But what I'm going to do next is I'm going to recognize that the order of the letters matters. So that means UM corresponds with FS. It also means that MC corresponds with SP. And then it means that CU goes with PF. Therefore, we can show that these 3 pairs of angles are congruent, these 3 pairs of sides are congruent, these 6 congruent statements can be made given the triangle congruence statement. Okay? So again, let's label that. UM corresponds with FS, MC corresponds with SP, and then UC corresponds with FP. All right? So it's not flipped, it's just rotated. And so you can sometimes have a visual miscue when you are looking at the figure. All right? You want to make sure that you are attentive to the fact that this figure would actually look like this. UMC up at the top. So that you can see which parts go together. Next, where'd my clicker go? There we go. The other thing that I want you to mention or want you to recognize is sometimes while we can have that visual miscue, we want to maybe be able to do the same thing just by looking at the congruent statement in no picture. So here's a picture where you have triangle dog is congruent to triangle cat. All right, I know that dogs aren't triangles and cats aren't triangles. Just trying to be cute here. I do not need a picture in order to identify the pairs of congruent angles. That angle D goes with angle C, that angle O goes with angle A, that angle G goes with angle T. I can identify that by looking at the order of the letters. That tells me which angles go with which angles, which points go with which points. And it also tells me which sides, DO and CA, go together, OG and AT, and then GD and TC go together. We can do that without a picture. Now sometimes students feel compelled that they need to draw a picture. Go ahead and draw the picture, that's totally okay. Draw that picture however you want, as long as you have the corresponding parts listed so that you can identify their corresponding angles and their corresponding sides. If the figures are congruent, then all of their corresponding parts are congruent. Let's take a look at this situation to think about that same concept but in reverse. We've talked about how congruent figures have corresponding parts are congruent. Well, conversely, if the corresponding parts are congruent, then the figures are congruent to each other. So again, thinking about a good definition, it's reversible. If polygons are congruent, then their corresponding parts are congruent. Flip that around. If the corresponding parts of two figures are congruent, then the figures themselves are congruent to each other. So here's what we're going to do. We're going to talk through each of these statements to make sure that we can address all of the parts and pieces. Do I have this in the, no, I don't have that in the PowerPoint. So let's talk through each one of these things. The first thing that I want to mention, and we're going to try to write it in a proof, all right? There is a lot of information that we are given here, all right? Knowing that this is marked 3 units, 4 units, 4 units, 3 units. These are actually marked congruent to each other, yay. We know that these angles are marked congruent. These segments are marked perpendicular, which means that these angles are right angles, which means that those angles are congruent. And then we also get to use our heads here and use unit 2, noting that these angles around point C, and we're going to have to name those angles using 3 letters, are also congruent to one another because, we'll tell you why in a minute, but hopefully you know why those 2 angles are congruent based on some unit 2 work. So here there are a lot of statements to make, and I'm going to overdo it here. I'm going to be a little excessive so that we can make this statement that yes, these sides are congruent, these sides are congruent, these sides are congruent. Yes, these angles are congruent, yes, these angles are congruent, yes, these angles are congruent. Therefore, the figures are congruent to each other. All right, so that's the punchline. Decide whether the triangles are congruent. Yes, they are. All of their corresponding parts are congruent. But it says to justify our answer using a proof. So we're going to start with, you can start with segments or angles. It does not matter. I would say if you start with segments, then list all the segments. If you're starting with angles, then list all the angles. That way you can note that I have all 3 pairs of corresponding sides congruent. I've got all 3 pairs of corresponding angles congruent. And we're ready to rock and roll. So the first thing I'm going to say is that segment AB is equal to the same thing as segment ED. All right? I'm going to go ahead and say that this is given information. All right? Which means that those segments have equal measure by the transitive POC, and therefore those segments are congruent to each other. By the definition of congruent. Now again, it's a little excessive to list all those parts and pieces, all right? But we recognize, hey, they have the same length. That means that they're equal to the same thing. That means they're equal in length to each other, and therefore those segments are congruent. That's the first segment. We also have the same thing with BC is equal to 4, which is the same thing that DC is equal to. That's given information. And therefore, the length of segment BC is equal to the length of segment ED, because of the transitive POC. And therefore those segments are congruent by the definition of congruent. All right, we're using, again, postulates, properties, definitions, theorems to make our statement, to make our reasons. So I've got 1 pair of sides congruent, I got another pair of sides congruent. Let's do the 3rd pair. Well, you know what? They gave that to us. They told us that CA is congruent to CE. That's given. Yay. So I don't have to overthink too much with respect to that statement. All right? We can tell that all 3 pairs of corresponding sides are congruent. But now we have some other statements to make. This just dealt with the 3 pairs of corresponding sides. Now I have to deal with the 3 pairs of corresponding angles. So I've got more, but I'm running out of space. I'm going to go ahead and I'm going to start with angle A and angle E, because that's given. And I'm going to do the angles around C for my other pair of angles. I've got angle ACB is congruent to angle ECD by the vertical angles theorem. Hopefully you knew that. Vertical angles are congruent So the vertical angles theorem there states that those two angles ACB are congruent, or angle ACB is congruent with angle ECD. We have that last pair of angles around points B and point D. Now, we talked about this a little bit in Unit 3, specifically in the 3132 proofs lesson and the 3.2 lesson itself, talking about perpendicular lines, and the definition of perpendicular being that when perpendicular lines intersect, they make 4 right angles. If two perpendicular segments, or two segments are perpendicular, then they make right angles. So we're going to say this statement, and this is going to then continue this down here. I'm going to say that segment AB is perpendicular to segment BD, and I'm going to say that segment ED is perpendicular to BD. This is given in the picture. That's what this symbol means. All right? But that means that the angle at B and the angle at D are right angles by the definition of perpendicular. If those segments are perpendicular, then those angles that are formed are right angles. And then we know that all right angles are congruent. Theorem 2.4. My very last statement, decide whether the triangles are congruent. I need to make a triangle congruent statement. Now this is where it gets a little bit iffy. I've got 3 pairs of sides, I've got 3 pairs of congruent angles, yay. Got all the angles, side, side, sides, angle, angle, angle. Now I'm going to list that triangle ABC is congruent to this other triangle. But what is the name of that other triangle? Can I call that other triangle CDE? If I'm reading that right, then segment AB would correspond to segment CD. Is that true? We can't just list the letters in some alphabetical order. That is not how we name triangles appropriately, all right? Now, you can name that triangle CDE, and you can name that triangle ABC, but triangle ABC is not congruent to triangle CDE. The congruence statement tells you which parts are congruent, and A doesn't correspond with C. And B doesn't, well, B does correspond with D, but C and E don't correspond to each other. And segment BC doesn't correspond to segment DE. So we've got to be very careful with how we name the figure. All right? If I'm going to use ABC, which is totally fine to list the first one alphabetically, ABC, that's great. All right? AB corresponds with ED. And BC corresponds with DC. So I can say that triangle ABC is congruent to triangle EDC. My reason, sorry for the handwriting, definition of congruent triangles. Or we could say definition of congruent polygons. I said triangles because we're dealing with triangles. We've got 3 pairs of corresponding sides congruent, 3 pairs of corresponding angles congruent. Therefore, the triangles themselves are congruent because all 6 pairs of corresponding parts are congruent. Following that up, we want to be able to look at a situation and conclude whether or not a pair of triangles are congruent. All right? And so sometimes we have enough information, other times we don't have enough information. Other times when we look at the picture, we're like, hey, these 2 triangles aren't congruent. But we have to look at the markings as well. Can you conclude that the triangles are congruent given this information? Well, I've got a pair of angles. These angles are congruent, these angles are congruent, and then these vertical angles are congruent. Yay. So all 3 pairs of angles are congruent. Sweet. However, I don't have this side corresponding and congruent to any of those 2 sides in the other triangle. Basically, I have 2 isosceles triangles here. All right? And so I don't have a corresponding side from one figure congruent to I don't have a side from one figure congruent to a corresponding side in the other figure. All right? These markings, again, mean that these 2 are congruent, that these 2 are congruent, but none of them are necessarily congruent to one another. All right? So my answer here in example 3 would be, no, there's not enough information. And I would say, no congruent sides. Now when I say no congruent sides, I mean between the 2 figures. I could say no corresponding congruent sides. That would be a better sentence. But if you say no congruent sides, I'll know what you mean. No corresponding congruent sides. If we don't have any corresponding sides that are congruent, I cannot say that we have congruent triangles. All right, our first theorem of the new unit. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So what this means here is if I'm given that these are congruent, and I'm given that those are congruent, then I know that these have to be congruent. Notice how the triangles aren't congruent here, all right? So that is not necessarily that we have congruent triangles, but typically we're going to be applying this in a situation where we want to show that the triangles are in fact congruent to each other. All right, so if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles will be congruent. So here's what I will say, all right? If this is x and this is y degrees, then this is x degrees and this is y degrees, all right? If we know that those angles are congruent, then we know that their measures are equal, all right? Now what I'm going to do here, though, is I'm going to have this angle is a degrees and this angle is b degrees. What I'm going to show in this situation is I'm just going to use a little bit of the triangle angle sum theorem and the constraint that it puts on our algebra. I will say that by the triangle angle sum theorem, this sum is 180 degrees, which means that if I were to subtract x and y from both sides, then I would be left with a. But at the same time, in this other triangle, I've got very much the same equation. X and y and b add up to 180. And therefore, if I subtract x and y from both sides, I have b is equal to 180 minus x plus y. Well, if a equals 180 minus x and y, and b equals 180 minus x and y, then therefore, a and b must be equal to each other by the transitive POC. And if those values are equal, then those angles are congruent. There's the logic there. I didn't quite write it as a two-column proof, but you guys get the idea. If two angles of one triangle are congruent to two angles in another triangle, then the third pair of angles are congruent. So let's use this theorem 4.1 in this proof right here. All right? Yes, this is a proof. Yes, we're going to write two-column proof. We're going to make at least 7 statements, because we're going to show that we've got 3 pairs of sides congruent, 3 pairs of angles congruent, and then we have to write our triangle congruence statement. So we are going to use the information to prove the triangles congruent, the triangle. So it didn't say which triangles to prove congruent, but hopefully we can figure that out. Hopefully we can make the triangle congruence statement correctly. So please watch through this, all right? And then if you need to go back on the video, go back on the video. But please just watch, okay? Pencils down, watch this. We're going to note that we have some key information here. We're going to note that segment PQ and segment PS are congruent. That is given information. We're going to note that segment QR is congruent to segment SR because it's given information. And then we're going to note that this segment that connects point P to point R is a shared segment, right? It's in both triangles. And so it's congruent to itself. RP is congruent to RP. We got to think back to the reflexive property of congruence. The reflexive POC here says that this segment is congruent to itself. It's a shared segment. It's not like it's overlapping. It's the same exact thing. And so obviously it's congruent to itself. These are congruent to each other, these are congruent to each other, and this is congruent to itself. So we've got 3 pairs of sides. Now let's talk about the 3 pairs of angles. The angles at P. Now look how we had to name those. I couldn't say angle P is congruent to angle P. I've got to use 3 letters. Because if I say angle P, there's 3 different angles here. There's this angle, and then there's the combined angle that makes angle P. So which angle P are you talking about? Let's be specific. RPQ is congruent to RPS. So this angle and this angle. And that is, again, given information. So here we're making it as easy as possible, giving you as much information as possible. All right? And then we're also going to say that these angles are congruent. Now you'll notice I skipped the angle at Q and the angle at S. But I know that QRP and SRP are congruent because that's marked given. So how do I know that these angles are congruent? I can't use the vertical angles theorem. I can't say all right angles are congruent. I can't use congruent supplements theorem. I could do some work there and say, well, these angles are going to add up to 180, and then we can subtract the same. But we just had that proof on the previous slide where we described and discussed the fact that, hey, if we've got 2 pairs of angles congruent to each other, then the third pair of angles is also congruent. All right? And so our very last statement there is that that angle Q and angle S are congruent. I don't have to use 3 letters there. If you want to be safe, you are welcome to. But these angles are congruent because of the third angles theorem, or theorem 4.1. All right? So now we know that we've got 3 pairs of corresponding sides congruent, 3 pairs of corresponding angles congruent. Therefore, I can use the definition of congruent triangles to show that triangle PQR is congruent to triangle PSR. All right, hopefully you watched that. Now go back and write it down, pause the video. So that brings us to the end of this lesson. Our goal here was to recognize congruent figures, and so you might need to look at them as, oh, these overlap. All I need to do is slide it. Sometimes it's I need to flip one so that it will match the other. It's a reflection, and other times it's just a rotation. All right. Well, I guess I'd have to flip it this way. I have to rotate those so that they do match up. So hopefully we can recognize congruent figures and identify their corresponding parts. If we know that their corresponding parts are congruent, then we know the polygons are congruent. If we know the polygons are congruent, then we know that the corresponding parts are congruent.